Hey, this is Bill Kennedy. I decided that I wanted to build a new application to do some meetup work, webinars, and training leveraging Dgraph. And I thought it would also be fun to start learning how to work with the Twitter API to do this. So the idea is that we're going to build a fairly simple but still production-oriented application that works with Dgraph, works with Twitter, to have a little fun. We have a larger DeGraff project that I've been working on for the last 3 months that I will be stealing code from. There's no reason to reinvent the wheel, but I'm hoping that this is a little simpler, and it may also add value as you watch kind of me work, hit walls, walk through walls, get things to work, refactor, again towards that idea of programming, getting things to work, to engineering, getting things in a place where they are maintainable for the longer term. So let's switch back over to my computer here, and you'll see that there is a Ardan Labs DeGraff repo that I started a couple of days ago. I've got some initial code in there that we're going to review and go through, so we can then from there start working on it. The other repo you're going to see me stealing work from is this one here, which is under Dgraph-io called Travel, which I've spent months on really learning how to work with Dgraph and GraphQL, and that's what we're going to be leveraging in this little app. Maybe even do some UI work if or when it makes sense here. So I'm going over to my terminal window here. I'm in the Ardan Labs Dgraph folder. I'm going to go to the Dgraph.io travel folder as well for when we need to kind of steal some code there. I'll bring that up on VS Code, listen to me talking, as well. And I've already got our Dgraph app that we're going to be working on here. There's already some code, as you see, submitted that I worked on. Oh, sorry, wrong repo. That I worked on a couple of days ago, and then I decided to stop where I was, and I thought it would be better served if we build this out together here in this video format. So let's break down where this project is at least right now, and then where we are going. So one of the very first things that I needed to do was verify how the Twitter APIs work that I wanted. The basic idea for this app, Eric, switch back over to me. The basic idea for this app, and again, to kind of keep it simple and leverage what we have, is I want to give it a certain person. And this is a problem that I've kind of, I don't know if we can solve this particular problem, but I know it would be, this would get us on the way to doing that. One of the things I've been interested in on the Twitter side is reducing noise in my feed, right? So I'm kind of dropped, I'm down to about maybe following 200 people. And it's not because I don't want to follow 2,000 people, it's just that if I minimize the amount of people I'm following, I feel like I get higher quality tweets that I'm looking at. And I rely on the fact in some cases that I know if I follow this person, these other people are going to show up in my feed anyway, so I don't need to follow them to get the same content. And that's really, I don't know if we can get there, but it's something that I'm interested in. So what I kind of want to know is, given the followers that I have, right, the 200 or something followers that I have, I want to know from these people who they follow. Okay, I want to know if there's any, say, duplication of the 200 that I have, and then who they follow maybe, right? And I think the idea would be, can I strategically maybe follow only 50 people to maximize the coverage of people that I would like to see in my timeline every day, right? I just find that that would be an interesting problem to solve. And it would reduce who I'm following and then maximize the actual people that I would see in my feed during the day, right? Interesting, right? So I think the idea for me right now is, can I build a database? This is more graph, I think, than anything else. So I want to build a graph database that, given an individual like me, all right, load up all of the people that I follow, and then maybe just one more degree, load up all of the people that they follow, and get to this point at least, right, in the development. So that's just alone a lot of work. And then once I have that, then we could decide how could I analyze the data in a way where I could maybe who should I be following in order to see all these people, right? And where the duplicates come from. And I don't know if I'm smart enough to do the final analysis, but I can't do anything unless I can at least get this information. So if we come back to my machine, one of the first things that I did was look into the Twitter developer Twitter information. I created an account with Twitter, and I started looking to see what APIs we needed. And I was kind of happy to see that all of this ran over HTTP. So essentially what we need is this call to, which call is it? A token, OAuth 2 token, with the Twitter API key and secret key that I got, that I have to hide from you, or I got to generate new ones, right? So I'm going to do my best. I'll probably make a mistake at some point. But we're going to have to make this call when we start out, so I can get a token. That the tokens don't last very long. So if you see a token, at this point I don't particularly care. But we got to generate a token on the fly, and then we can use these two calls here. And I can run this for you now because I've got my environment set up here. So this call is called IDs, and we can do it for any given person. Actually, I haven't even tried to do it for .net. So let's see how this runs again. So we're going to want to be able to make this exact call inside of our Go program here. So let's run that if it works. Good. So here are a bunch of IDs, probably no more than 200 or something, people that I follow. Let's, some of these IDs are big, right? So let's take one of these small ones because I'm not sure who that is. And then the idea is we can put that in there, and then I could get some core information about that person. And that lucky person was nobody that I'm following. So that gets interesting here. I don't think I'm following this person at all. So maybe this API isn't working. Let's take another number. I'm assuming that, oh wait, did I run the right one? Let's double check I didn't run the Twitter dev again. No, screen name go dot. So we may have to do a little more work in understanding these APIs here. Let's run this one here. I didn't even check it because I was using the Twitter dev to do this. So, oops. Yeah. So I don't know who these people are. So I don't know what that IDs did. So we're going to have to, at some point later on, figure out why this followers of ID screen name go.net. I mean, that's my handle. Didn't work. But I don't want to spend too much time here looking at that. So let's assume at this point this is working. I'm going to assume that this for sure is giving me the core data that I want, which is this information here. So at some point I can go back and validate why that follower list isn't necessarily what I'm assuming followers means the people I'm following, right? So if we just maybe go back and see if, yeah, of course, that's not going to work here. So Twitter APIs. If we come back here maybe and look at this, I'm going to have to figure this out. But I was basically on this page, and I went to followers IDs. That's the command that I called here. And I thought this returned a cursored collection of user IDs for every user following. Oh, for every user following me, no wonder. Oh, shoot. I don't particularly, I mean, I care, I don't, yeah. For what I want to do, that's not what I want. I want to know the people that I'm following. Okay, so we could find that, I think, API later, because I think at the end of the day, I still need the user call that I have here once I get an ID. So, and that's the call there to users show that I'm using. So these are people that are following me, not people that I'm following. So at some point we'll have to figure that out, and we don't have to do it on this video, but I'll do some research there. That's weird though that I don't see that obvious, and maybe that's not an obvious API, but let's not slow us down any farther than that. And if whoever's watching, well, by the time you see this, I think I'll have that resolved. But given that I know the first API isn't exactly what we want, the second API is, and if we just run the second API again, what I want to do is look at the data that's coming back. And a big thing I always say is if you don't understand the data, you don't understand the problem. And I really want to get a general sense of the information we can get on somebody that becomes important. And so you can see, I think here at the beginning, Twitter is giving us the ID of that user both as a number and a string. I think the string becomes more important here. We got a name, we got their handle, we got a location, and I don't need a lot of information about any given person to do this. I just, maybe their handle and location might get interesting later on, and eventually I have to also be able to get a list of the people that they follow, which again we don't know how to do just yet, but we'll figure it out. Okay, so unless maybe there's a URL here that gives us information about how to get to people who they follow. I'm scanning these kind of URLs and I don't see anything, but I promise we'll figure that out later. I don't think it's critically important. I can use these two APIs now just to get it working, and then eventually we'll get the right IDs for everything. But you know, that's life in the big city. Okay, so the first thing we need to do is we've decided that we wanted to I decided we wanted to use Dgraph to store the data. Dgraph is a graph database that's written in Go. I really love it, and I'm learning more and more about it. It has native GraphQL support that we'll leverage, and the fact that our APIs also just, our HTTP calls, makes it even better. So the first thing I wanted to do before we did anything here is lay out our project structure, set it up for modules, and start focusing on database stuff, and get the project set up also to be able to run Dgraph. So these are the things that I kind of have to go through initially with you here in order to get things running. Now, if you take my service class, you'll learn that I like building my applications in 3 different layers. And I think layering and not grouping is the way to go. And throughout this, we'll talk about some of the things I would talk about in the service class. So I'm going to have basically 4 layers here for any application that we're building. My application layer, which will contain all the applications and application concerns. I've already started building out an admin CLI tool so we can create the database schema and seed the database with some information. So we've got that we'll talk about. I've got the business layer, which is going to have our data layer right here. And you can see we've already done some schema work. We're going to talk about that. And a feeds layer, which I haven't really started yet, which is going to be used to make these HTTP calls here. I mean, there may be client libraries out there to do it already, but since this is just HTTP, let's just build it ourselves and we can control that. The platform layer is where foundational code is going to go. There's a good chance here that the feeds are probably more foundational in the sense they can be reused in different apps. But if we decide that we want to do some logging in these packages, then they have to come out of platform. I don't allow logging to happen at the platform layer. These should be really policy-free types of packages for the highest level of reusability. And then any third-party packages we're using, right now I'm going to be using a conf and a GraphQL package from Ardan Labs and Dave Cheney's errors package. I'm going to vendor that stuff into the project so it's all here. I've also already created this module file. So you can see here I'm naming the module Ardan Labs /Dgraph. We're running on 1.14, and you can see the versions of our dependencies that we already have. Another big part right away that we need to be able to do is be able to get the database up and running from DeGraff. Now, when it comes to running DeGraff here, I got Docker running here, so Docker images. What we're going to be doing, let me do a Docker system prune just to clean up all that stuff. So much garbage is left behind. Okay, so we're going to be running two different kind of versions of DeGraff, to be honest with you. We're going to be using the latest version, I've updated this a couple of days ago, of DeGraff standalone master and DeGraff master. Standalone is what we're going to be using to run our tests. Eventually we're going to want to write some tests. We'll use standalone for that. But what we're going to do is start off with a Docker Compose environment and run DeGraff the same way we would run it, let's say, in production. And eventually we can move over into a Kubernetes environment like Kind or something else here. Okay, and you can see I've got Kind already installed. But we're going to be working with the latest, greatest versions of DeGraff, standalone, and DeGraff. Okay, so what I've already done is started putting together a Makefile as well. I love Makefiles. I think they make it simpler to work with. We get to work off the root of the project as well. And you can see here that I have our Docker Compose, and I've kept the compose file right now at the root. Eventually, I think we're going to move that to kind of keep it out of the way, but this is a good place to start. Remember, we don't have to solve every single problem right away. We can refactor towards the solutions to everything as we go. And right now, this is not the most important thing, but we'll have our Docker Compose using the compose.yaml file to bring up the database, to bring down the database, to look at the logs for the database, and to be able to create the schema and then eventually seed some data in that database. We'll be able to run the admin tool out of app. And you can see how I'm just kind of doing a go run so we don't leave any binaries behind. And if we look at the compose file, eventually you're looking here. I don't have to break it down, but DeGraff runs basically as two instances, a 0 instance and an alpha instance, if we do it this way. And that 0 instance and alpha instance work together to form a distributed logical database that can scale pretty well. So this is how you would run it in a production environment. We'll use the standalone, which has a script inside of it that runs a 0 and an alpha kind of together for our testing. So we have that. Now I also have a keys file that I'm going to try not to show you. This won't be part of the repo. I will have it, or I should have it here. So let's add it just to make sure that that never gets in there. And that's where I'm going to be keeping my Twitter keys and stuff, so I can source that stuff on the command line. And hopefully I don't leak those out in the video or the repo. If I do, I mean, I can change them out, but I'd prefer we don't do that. And I'm also making sure if we do build binaries here, they don't get into the repo. So basic stuff maybe for some of you. For those of you who are fairly new to this, these are just, I think, some good practices to have in place and things that we want to do early on. Okay, so the key here is I want to define a schema for managing a user that's coming from Twitter, right? So again, some information related to this call here, and we'll be making this call probably quite a bit in relation to building this graph, right? Again, I got to find out what the API is for this, because I don't want people who's following me. I want to know the people who I'm following, but I'll get an answer for that. Okay, so I realized that we could start this in one of two ways. We could focus on feeds, but I think if I don't have a place to put this stuff, then that gets fairly complicated. So what I'd like to do, at least right now, is focus on the DGraph side of things. Make sure that we've got a place that we can store the data in, test and validate some of that stuff. And then in the next video, we can go ahead and start to build out the feeds layer, which is making those database calls. And by the time we get to that, I'll have that other API that we need. And then from that point, we can just continue to build on top of that, making sure that the data is working for us. Now, when it comes to DGraph, it's really important, especially working with GraphQL, that we have to define a schema. This isn't like let's say a MongoDB where there's no need to define a schema ahead of time. We do have to define a schema ahead of time. And by defining the schema, that also is going to be nice because DGraph will generate a full CRUD API for us that we can leverage. So I don't have to spend any time building out CRUD APIs. I just have to build out some Go support for the APIs that we're going to call and need. And really what we just need to do is insert data and all those relationships. And then I think we could always just kind of wipe that out and reload data for any user. So we can keep our database activity super simple. I think we just need to be able to drop data and then load all this data in one time, and then we can use it. So that would be kind of cool. Now, again, just keep everything inside our Go binary and to keep things simple. I mean, this probably should end up being in a file somewhere for a more production-oriented app that people can share. But I'm just putting it into a variable right now, which is called document, and I'm defining my GraphQL schema for DGraph. What's interesting about GraphQL schema that it looks and feels like programming, that it's based on a type system here. So we're going to have this type, maybe I can even put it down here so you can see it. We're going to have this type user. It's the only type we need, right? Everything in this app is a user and the relationship of users from there. So what I've decided is based on the data that I saw in this output here, I think what would be nice to maintain is somebody's Twitter ID as a string. And what this means here is that it's a mandatory, it can't be null, and it's mandatory, we have to have a string. The Twitter handle, now I want to be able to search on the handle, I think, so I'm saying @search. I really don't want to do an exact search. There's other filters. So once we load this up and I look at the schema in more detail, I'll remember what filter I want to search by, and we'll change that out. It's not important. But there's like 4 different ways that we can create an index against this handle field. And I think it would be nice to be able to do a query against the handle. I don't know. Right? I mean, right now, part of what we're doing is learning. If you don't understand the data, understand the problem. I think we have a general idea what the problem is. We just don't understand how the data relates to it. And I'm guessing a little bit here, so we're doing that. I definitely want the person's name. Location is interesting. I'm not making it mandatory right now. And we can get a followers count. So I'd like to know how many people they're following. So now I'm wondering if that means the number of people that are following them. So I think we got to reevaluate that field. But that's part of programming, right? We're trying to like break down the walls. And then I want a collection of people that they follow, right? So again, followers is already kind of cluing me that that's the wrong language here, right? It's not followers that are following this person. I want to know who they are following. So maybe what we'll do is we'll call this following, and we'll call this following, And so we come up with a better name for that. And again, we're going to have to look out what the APIs are. But it's okay. I mean, you don't know everything up front. So I think if we were able to capture this information with an idea that there's a collection of other users, and we can then do some analysis here. And I might even be structuring this data incorrectly to do the kind of inverse joins that I want to do. But we only have one type, and I don't think it makes sense to have a type following, which is another user that goes, it might. I mean, maybe this is something that we need to talk to the DGraph people about. Maybe I will by the time we get to the next video. But again, I'm trying to figure this out as much as anybody else, and I think this is a good place to start. So this document is right now the only type that I think we need in the system to do what I want. I could be wrong. We'll fix it if we are. And then we need some code to be able to execute the schema creation against DGraph. Now, essentially everything runs over GraphQL. And what's nice is, if I bring up vendor, github.com Ardan Labs, I wrote a GraphQL package. GraphQL is nothing more really than calling HTTP, and you know how much great support that Go has for HTTP. This package is, I would maybe argue, a little more tailored towards DGraph. And it essentially comes down to a single function called do. And if you were to look at this code, you would see it's HTTP, setting headers, calling client do, reading the body, checking things. I do have a line here that we can uncomment if we're getting in trouble for some logging. And like GraphQL data structure. So we're not going to go through this code. This is code that you can go through. It's out there in Ardan Labs. But this work has already been done. We can already issue a GraphQL query or mutation when we want. And I can execute some very specific DGraph commands if we need to. So just in the basic light of what we do with Go, I've defined inside the schema package a type called schema. Right now, it supports a GraphQL connection that will let us execute schema commands. And I thought it would be nice to just have a document that represents the schema that we want to create. Again, it's coming from a variable, but eventually, if we want, we can refactor that to a file. In the other DGraph project, I actually use Go templates because there is information that has to be filled in to the schema based on configuration. And so kind of leverage the same idea, and the schema may come from anywhere, and it may need some text processing. So we've got our schema type, and we've got our factory function, and it creates a GraphQL connection. I've put that information in the data layer. Okay, we even have a package called data for getting those GraphQL connections. We can talk about that later. It's not critically important. We have a GraphQL config, and we essentially need the URL to the DGraph server. And if we're doing authentication and authorization, which we aren't right now, but we could, we need auth information, and that uses JSON web tokens. That will be empty for us. We do need the URL, and we'll look at that. So we'll construct that, and I think essentially we'll need the drop all, though I don't think we'll need to drop the schema when we do this. We probably just need to drop the data, so we can maybe make some changes to this code later. You can see here we're going to construct some GraphQL, and we're going to call into the server. There's nothing that going on. This is an important function, create. And one of the things we'll do is we'll retrieve the existing schema out of the database. We'll validate that. If it doesn't match, we'll do a create, which is also like an update. If it does match, we don't have to do anything. This is your basic DGraph mutation call to update the schema in the database. You'll see that we'll define this with a variable. We'll set that variable in a map, and that map gets sent over with the HTTP call. And then DGraph kind of assembles everything together. So the key is basically that we have a schema document, and we can substitute it here. Then we'll retrieve that schema again, and we'll validate that what we thought, that what we tried to set is valid. That's the retrieve call. Again, it just does a query to retrieve. We saw some of that code. And then I have to do some really nasty things to validate. So this code here under schema is code I took from the other travel project. I know it works, and it just wasn't anything that I felt like we needed to do manually here. That would have been a lot of copying and pasting. So you can kind of look at that. But I want to validate that this code works, at least on this video, and make sure we can talk to our DGraph server so we can then move on to working with our Twitter APIs. So we need an initial application to do that. So at the application layer now, what we're going to have is our admin tool. Now, what you're going to see me do in any application that we write is a main function that's going to create the logger that we're going to use. We're going to use a standard library logger. We're not going to use singletons. We're not going to hide loggers in context. Everything has to be passed with the highest level of precision everywhere it needs to go. And so we'll have a unexported name function called run. It takes the logger, and we're going to do some things. And you'll see this again with every application that we build. First thing is we've got to deal with configuration. So what we're going to do here is define some base configuration parameters with defaults, with the idea that the defaults should work hopefully in every environment we have, and where it's not, we'll handle that separately. So when we run DGraph in that composed container, we should be able to access it from the outside using the 0.0.0.0 interface, and all GraphQL runs on 8080. So that default should work. We're not going to do anything with tokens, but we do know that that xtravel auth is a default name for that. We can leave it in there. I can leave it out. It's not important. I can't set a default for my Twitter key, the token, and in fact, based on what we learned, we're really going to end up with two fields there. We're going to need two keys with the way the Twitter handle works. We'll fix that later. We're not ready to do feed stuff yet. And that's going to have to come from the environment. So what's going to happen is we're going to define this config struct. We're going to parse, we're going to use pointer semantics to pass that into a parse function, which will look on the command line and in the environment and override any of these defaults, or set the defaults first and then override those defaults. Again, we're going to have to work on this. This isn't going to be just one key that we're going to need. We can display usage if we ask for help. We can display version information if we want to set that. In the service class, we go into large details about these things. We're going to log out what the current configuration is so we know that what we have is working. And I'm going to want to hide when we get there some of this key stuff so nobody sees my keys. Though again, yeah, we're not going to want to show that. Then we'll set some GraphQL stuff here. And the only command we have right now here at the end of main is schema, which we'll call into the commands package. And then from the commands package here, you can see a commands.go, which is really not going to have much in it. We're going to break the commands up by name. And this is going to be our schema. So what we're going to have here is the call to new to construct a new schema. We'll set a 20-second kind of timeout to get that schema created. And then we'll call create from the schema package that we have. And we basically, with this code, have the ability now to create a schema in DGraph. We don't have code to do much else just yet, but we have that. And I want to validate that this is working. So what I'm going to do is, again, come back to the command line, and everything that we do we'll put into our Makefile. So let's do a make up to get the database up and running. There it is. So we've got our 0 and our alpha running. We know that's all working. We can do a docker ps. There it is. And now what I want to do is see if the schema command works. So we can do a make schema, and boom, there we are. The application ran. We can see the configuration that we used for that. I don't see any errors. Schema updated. But how do I know it's really working? This is where there's a tool right now called the GraphQL Playground. That's something that you can download. Let's go look at GraphQL Playground. for this project, it may not necessarily be bad to download that. I think there's a, yeah, maybe I used Brew for it. I don't remember. I probably did. So looks like Brew has an install for the GraphQL playground. It's a nice tool. It gets us started until we have enough Go code and testing to carry us the rest of the way. So we need the endpoint, which is HTTP 0.0.0.0 colon 8080/GraphQL, and we're connected. And I know everything's good because I've got that schema tab on the other side there. So I'm going to try to zoom in a little bit and bring in the schema. So this is our schema, and you know, it may not be bad to just copy this into the project right now. Right now what I'll do is I'll add a file, schema. It's not anything I want to save with the project, but it will, and maybe what I will do is save it with the project for now. So rename, so you can see it, and maybe we'll call it schema GraphQL, and we'll just leave it here at the root so you can see it. Now, even though our schema only had one type in it, which is user, what's nice here is that Dgraph generates a bunch of CRUD-based types that we need, like adding a user, a payload after the add. We're not doing any auth or custom stuff just yet. You could see the scalar types being defined that we might need, support for deleting a user. And honestly, something I did miss here, that CRUD support came into existence primarily because of this field. And this, what it does is generates a unique ID for each node of data, and it's also the quickest, you know, a fast indexed kind of way of getting to the data. But by having this big ID field here, we're getting a full CRUD API built into the database kind of for free. You could also see there's a float filler type, int filter. This is what I was looking for here. So Dgraph has given us a full mutation API now that we can use to add users, update users, and delete users. And it's given us the query commands that we need to get a user by ID or to query a user based on the user filter. Now, we used exact, right? Which I told you I don't think I want to use exact. I think what I want to use is this, full text. And that will let us kind of filter or do searches without having to obviously be exact here. So you got full text, hash, reg, or maybe a term filter might be better. We can play with that too when the time comes. But these are the different options that we have. If we go back to our schema here, when I had exact here, then we were talking about this, right? Equal, less than, greater than equal. But we could set that to full text. We could set that to hash, regular expression, term, and we'll figure out what we want to use later. Update payrolls, and you can see here following. Now this is interesting because I don't know where all that came from, following a user. So this is stuff I may want to talk to Dgraph about later on to get a general sense. But it looks like it created that relationship that I was hoping for, I think. So we'll find out. User filter. So the entire type system is here, right? It's pretty cool. And what's also nice about, even though I'm going to keep this here, because it's nice to have a reference when you're just starting to write code. They also have some like docs here that we can go through later on that show us how to make one of these calls here. So type details, user filter, and we could, you know, even manually code this right now if we wanted to. I'm not going to do that. We're going to code this stuff in Go, and then if it's not working, we can always come back here and validate it. But that schema call did work. So we're at a point right now in this project where we have the ability through a simple app right now to create that schema, get the database loaded. I can now bring the database down, get the database loaded, bring it down, create a schema, and we're ready. Eric, show me. We're now ready actually to now focus, since we have a place to put the data, to focus on getting the data we need. And I do have to do a little research to figure out, not to find the people that follow me, but the people that I follow, because that's the real data that I want. So for this first part of the video, we haven't done any live coding today, but this version of code is up in the repo. What I'll do is tag this code as video 1. So you can see this code here after I push a couple more of these changes. And then when we come back here, again, we'll start with video 1 code, and then we'll start to add all that HTTP code we need in order to get the Twitter data out. And we'll start to build out the small APIs that we need to call Dgraph to get that data in. That's what we'll do on our next video.